Hey everybody, welcome to another support video. This one's on Understanding Linear Functions, version 5 and 6. This is for my class. Generally speaking, if you're not in my class, then you're just going to watch this to help you learn how to write y equals mx plus b equations for lines given to you on a graph, and then how to find solutions to systems. So if you're trying to figure out how to solve a system of linear equations, this would be a good tutorial for you. But for most of us, we're just going to be correcting it, right? So let's go through and go through the process and see if we can figure it all out. So the first thing is line number 1 here. It says find the equation of each line, use y equals mx plus b, which is your standard slope-intercept form of an equation of a line. And so the way we do this most efficiently is the first thing you want to do is you want to identify the slope and one of the ordered pairs. So I'm just going to go through here and we're going to identify an ordered pair. Let's pick this one right here. And that one is x value of -10 and a y value of +8. So we have one ordered pair on that line. I would grab a second ordered pair on the line just to make sure that we have a way of checking our answer. So that's at -6 and 7. So -6 for x and 7 for y. And then I would just go ahead and take a look at the slope here. That's the slant of the line, change in y over change in x, and the staircase of movement basically along the line from one point to the next. And if you're looking at the point on the left and we go to the point at the right, we're basically going to realize that we have to go down 1 unit. So a change in y is going to be a -1. Okay, and then we have to go to the right 1, 2, 3, 4 units. So that means it's going to be change in x direction of 1, 2, 3, 4 plus 4. So ultimately, your slope is going to be a ratio of -1 over +4, change in y over change in the x, right? So this is the staircase of movement along the line, down 1 to the right 4, down 1 to the right 4, down 1 to the right 1, 2, 3, 4. That will be the next dot on the line, and then down 1 to the right 1, 2, 3, 4. And you guys will see something special happen there, right? It's going to cross this line exactly at that ordered pair. All right, so anyways, that'll be in the future, though. Let's take a look at right now. I just writing the equation for this line. And the equation for this line is going to be a slope of -1/4, going down from left to right, gradual slope. And the ordered pair we're going to use is -10, 8. So let's go down here. So we have a slope of -1/4. We have an x and y of -10, 8. And so we have an m, an x, and a y. All we got to do is find the missing y-intercept. So once again, you guys know it's y equals mx plus b, where m is the slope and b is the y-intercept. So just plug into that equation and solve for the missing y-intercept. So you get the y value is equal to the slope, which is -1/4, times the x value, which is -10, plus the y-intercept. And so that ultimately becomes 8 is equal to positive, and 1/4 of 10 is 2.5, right? So basically we're looking at +10/4, which is 2.5. So we're looking at 2.5 there. So positive 2.5 plus b. And then we want to get the b by itself, so we want to take away 2.5 from both sides. And what you guys can see is 8 take away 2 is 6, and then take away half is 5.5. So we're looking at a y-intercept of 5.5. So we have a slope of -1/4 and a y-intercept of 5.5. So our equations mean y equals -1/4 of x, and then plus 5.5. And just to make sure that it makes reasonable sense, let's go back up here. And does it look like if we extend this line out, it crosses at 5.5 on the y-axis? So when we extend it out, we can see that they do intersect there, and it looks like it does cross the y-axis at 5.5 there. So pretty much what we expected. So let's kind of go that away. We're good with that line. So we have line number 1's equation there, and we feel pretty good about it. You can always check it with the other points, so I'm going to do that real quick. So I just take that -6 and 7 ordered pair, and let's just check it with that. So we'll do a little check here. Let me change that to a writing utensil. Awesome. So do a little check with -6, 7. And you just plug it in and check. So -6 times -1/4 is +6/4, which is 1.5. So 1.5 plus 5.5, is that equal to 7? Yes, it is. So when you plug in that x value of -6, you do get a y value of 7. So that is correct. We have this check that this ordered pair is on the line. So that means we have the correct equation of the line, right? Because both of the ordered pairs are on the line we thought they'd be on. Okay, let's take a look at line number 2. Line number 2 is a very positive slope. It looks like it's going to be pretty steep. So it's going to be an absolute value greater than 1, and it's going to be positive. Let's identify two ordered pairs here. So this first one here in blue that I'm going to identify is the ordered pair 2, 5. So that's one of our ordered pairs. The other one I'm going to use right here is this one that is over 1 and up 2. So that's an x value of 1 and a y value of 2. The slope of this line, staircase of movement along the line, is going to be a change in y of up 3 and a change in x of to the right 1. So we're looking at positive 3 over positive 1 as our change in y over change in x. So we're looking at 3 over 1 for our slope. So that means our slope is going to be just 3 over 1. Now that we have our slope and our 2 points, we can find the equation of this line. So we're just going to go down here. We know that the slope of that line number 2 is 3. And that the x and y ordered pair that we're going to use there to find the line is 2, 5. So that's going to be 2, 5. We have this x, this y, and this m. Plug into y equals mx plus b. You get 5 is equal to the quantity of m times the quantity of x plus whatever the y-intercept is. So 5 is equal to 6 plus b. You want to get b by itself, so subtract 6 from both sides. And you can see that b is equal to -1. Okay? So you have a b value of -1 there. So we know our equations mean y equals the slope, 3, times all universal x's, and then -1. Okay? So this is our equation. We want to check it to make sure that it is reasonable. Our checkpoint is going to be 1, 2. So let's grab our checkpoint of 1, 2, and see if it does in fact work. All right? So check with 1, 2. Let me do that a little nicer for you guys. When you plug in a 1 value for x, do you get a y value of 2? Well, 1 times 3 is 3. 3 minus 1 is in fact 2, so it works. So now I feel very confident that we have the correct equation of that line. Now let's go take a look at the next one here. The next one is this line number 3. We'll do this in purple. So ordered pairs, let's identify 2 of them. The first one we have here is -7 and then down 4, so -7, -4. The second order pair we have is -11 and then down to -7. So we're looking at -11, -7. The slope of this line looks to be positive. It's going up from left to right. It doesn't look like it's quite 1. It looks like it's a little less than 1. Let's find out what it is. So if you take a look at the change in y over change in x, you'll find the exact slope. It's going to be from one point to the next. The staircase of movement is up 1, 2, 3. Okay. And then to the right, 1, 2, 3, 4 units. Okay. So that means that our slope here is change in y of positive 3 and change in x of positive 4. So this is a slope of 3/4. Like we said, it looked like it's positive. I thought it'd be a little close to 1, but not quite 1. And that's what it was, 3/4. So now we go down here. We know our slope is positive 3/4. So m is equal to 3/4. And we know that our x and y that we're going to use to solve is going to be, let's do -7, -4, one of the 2 points. So let's do -7, -4. And we have our x, we have our y, we have our m. All we got to do is plug into y equals mx plus b. So for this particular equation of a line, we know that the y value is going to be -4 when the m is 3/4 and the x value is -7. And then obviously we have to add our y-intercept to that to get it all balanced out properly. So 3/4 times -7 is going to be -21/4. So this is -4 equals -21/4 plus b. 4 goes into 21 5 times with 1 left over. So this is -4 is equal to -5 1/4 plus b. And then if I scroll down, we can see we're going to add 5 1/4 to both sides. So add 5 1/4 to both sides to get b by itself. And the positive wins by 1 1/4. So we can see that the b is going to be 1 1/4, which means that our equation for this line is going to be y is equal to the slope 3/4 times x and then plus 1 1/4. And let's just check to make sure that this makes sense visually. So when we extend this line out, does it look like it's going to cross at 1 1/4? Yeah, it does. So I feel pretty confident with that. And also we notice that if you extend the line out, it will intersect right there, it looks like, on the other line. We'll talk about that in a little bit. All right, so awesome. So there you go. We have that. Let's just check the answer here with the -11, -7, and see if that is in fact on the line. It should be. So let's check this. I'm going to change that to a writing utensil again. Keep forgetting to do that. Let's check this with negative 11, negative 7. So negative 11 times 3/4 is going to be negative 33/4. This is like 5/4. So it's negative 33/4 plus 5/4 is going to be negative 28/4, which is negative 7. So it works. Cool. All right, so we've done everything correct. We have the y equals mx plus b for those 3 lines, line 1, 2, and 3. Now it says, where do lines 1 and 2 intersect, and where do lines 2 and 3 intersect? So the first thing you want to do is you want to extend the lines out to see if you can just identify where they intersect by moving the slope. So if I'm looking at this one here, and I'm moving the slope is down 1 to the right 4, down 1 to the right 4, down 1 to the right 4, down 1 to the right 4. And we can see exactly that these cross at that little dot right there perfectly. So this ordered pair here of 2, 2, 5 is where line 1 and line 2 intersect. So that's easy. So that's the solution to the system. So where do lines 1 and line 2 intersect? Lines 1 and line 2 intersect at the ordered pair, just make sure I get that right, is 2, 5. Okay? So that's the ordered pair 2, 5. And then where do lines number 2 and number 3 intersect? So if we start, let's say, at number 3 here, and we move the slope here, let's just see what happens. So if we grab our little purple here, and we move the slope, it's up 3 to the right 4, up 1, 2, 3 to the right 1, 2, 3, 4. And then we'll do it again, move it again, up 1, 2, 3, and then to the right 1, 2, 3, 4. Oh, perfect. They intersect right there. So this point 1, 2 is the point of intersection between these two lines. So the nice thing about this is what we're seeing is that for both of these lines intersecting both these situations, it's a perfect nice integer that you can just find by moving the slope and seeing where the lines connect, right? So the intersection point is the solution of the system. It happens to be 1, 2 for the second answer there. All right, now obviously, we can trust those based off the graph. It was really easy to see that those are the places of intersection. But if I wanted to, let's say, explore further and find another way to solve for that algebraically, here's how you could do it. So if you have lines 1 and 2, let me just kind of extend this out for you guys here. I'm going to upload this and then open up a new page real quick. Yeah, let's add a page for graphing here. Let's do 2 for 1 out. Okay, so basically what you're going to do is you're going to substitute the y values from one linear function into the other. And that basically is, some people call it the equal values method, some people call it just substitution. But it's going to be really helpful to see if you can do that and find out where the y's are the same is basically the x position where the y's are the same. So let me show you. That sounds complicated. It won't be very complicated once we do it. So for lines 1 and 2, we know that this is the equation y equals negative 1/4 x plus 5.5. So let's go here and write it out. So this is for version 5. So version 5, we have line number 1, which was y equals negative 1/4 x plus 5.5. It's a little memory game. Y equals negative 1/4 x. Did I get that right? 1/4 x, yeah, plus 5.5. Okay, plus 5.5. And line number 2 was y equals 3x minus 1. Okay, so line number 2 is y equals 3x minus 1. And what's cool about this is all you have to do is you just take the two y values and you set them equal. So you take this y value and set it equal to this y value. And basically what you're doing is you're just setting the y values equal in terms of x. And the other way you could think about it is you're substituting in. It's like you're taking the y value from 1, you're taking the y value from one of the lines. Let me do that in a little bit nicer form. Y value from one of the lines, and you're substituting in for the y in the other. So basically, you're substituting in the value of y based off of the other line. See how that works? Okay. So when you do that, what you get is you get 3x minus 1 is equal to negative 1/4 x plus 5.5. And the nice thing about this is it only has one variable, so we can solve it. And what it's going to do is it's going to give us the x location of where they intersect, right? The x location of the shared ordered pair that's the solution to both lines. And so now all we got to do is get rid of this 5.5. So I would change that to 11 halves. So you get really 3x minus 1 is equal to negative 1/4 x plus 11 halves. And then I would multiply that whole thing by 4, so we can get rid of our fourths and our halves. So 4 times 3x is going to be 12x. 4 times negative 1 is going to be negative 4. 4 times negative 1/4 x is negative x. And then 4 times positive 11 halves. 2 goes into 4 twice. 2 times 11 is 22. That's going to be plus 22, or if you think about it, just 44 halves, which is 22. Once you have this, you can solve for x. You're going to add x to both sides. You're going to add 4 to both sides to get the variables to one side and the numbers to the other. You end up with 13x is now equal to 26. How do you want to do times by 13? Divide by 13 both sides, and you get x is equal to 2, which means that the intersection point is going to be 2 comma something, right? We got to find out what that y value is. So just pick either line and plug that x value in, and you'll find the ordered pair. So let's use this one on the right. It's very easy to use. So we do y equals 3 times whatever the x value is that we just found, 2, and then minus 1. So y would equal what? 6 minus 1, or 5. So we can see that the ordered pair where they intersect is 2 comma 5, which is the solution of the system. And this is how you'd find it algebraically if it wasn't easy to spot on the graph. Okay? And then you can check it always, right, by plugging it into the other one, because it should be a point that's on both lines, obviously. So if we check it on the other one, this 0.25 should be on the other line as well. And we can see that y, in this case, y would be 5, right? So we know that 5 is equal to negative 1/4 times the x value of 2 plus 5.5. And that means that 5 is equal to negative 2/4 plus 5.5. Which basically is telling you that 5 is equal to negative 1/2 plus 5.5, which is obviously 5. So we can see that 5 does in fact equal 5, and that's true as well. So ultimately speaking, we can see that the intersection point that we came up with, 2 comma 5, exists on both lines, and it is basically the solution to the system. Not sure why that keeps happening, but there you go. So that's how you do the first page, and that's 2 ways to find these, either using the graph and just looking at the slope of the movement and recognizing where they cross, or algebraically solving using the substitution method. All right, so we'll do the next video next time. All right, hope that helps.